see. Camera angle's a little different. All right, so this is going to be continuation on 3.5 again. So I'm just going to say continue 3.5 again. Okay, because we did it kind of in 2 sessions last time too. We ended last class talking about slant asymptotes. So I want to make sure that we know how to do that in different situations. So when I say find all asymptotes, that means I want you to tell me the vertical, the horizontal, and the slant ones. Okay, remember slant asymptotes don't exist with every type of equation. So let's say that I gave you this equation. X cubed plus 1 over x squared. Okay. So let's just kind of run through our list, right? So I'm going to remind you of how we do these. How do we find the vertical asymptotes? Remember, you simplify first, which notice there's nothing to factor / simplify, and then you set what equal to 0? Well, not x. You set the denominator equal to 0. I think what you're thinking about is already what the answer is going to be, which is fine. Okay. So if you set the denominator equal to 0, notice we'd get x squared equals 0, which is just x equals 0. Okay, so there's a vertical asymptote at 0. Remember that I want you to write those as x equals. Okay, and for the horizontal asymptotes, remember they look like y equals. For the horizontal asymptotes, we have 3 cases. Okay, remember we compare the powers on top and bottom. That's the 3 cases. So I'm just trying to jog your memory for what we did last time. But note that the power on top is bigger. And if the power on top is bigger, what's the conclusion? No horizontal asymptote, that's right. Okay, if it's anything bigger, the power, then there's none. What if it's smaller? What was it, just to remind ourselves?
0.
If it's smaller, it's 0, y equals 0, and then what if they're the same? What do you do?
The leading coefficient.
Yeah, like pull the top number over the bottom number, and that's it, right? So a slant asymptote, first let's talk about if this has one and why. Okay, so remember, note, or pay attention to the fact that the power on top is 1 bigger than the power on bottom. So that's the key. So because it's exactly 1 bigger, what does it mean? There is one. Okay. Notice there'll never be both a horizontal asymptote and a slant asymptote at the same time, because if the power on top's anything bigger, there's no horizontal asymptote. Okay. So remember, what we're supposed to do is divide and ignore the remainder. And whatever we get for an answer, that's the equation for the slant asymptote. Okay. So this is how we always find the slant asymptote. So let's come back up here, right? Notice we cannot use synthetic division here. How come? Remember, synthetic division is only when the bottom is something like what? It has to be like x plus 1 or x minus 5. It has to be x plus or minus a number, okay? So note that we have to use long division here. But luckily for us, that's not that difficult. Okay, we have to use long division because we're dividing by something more complicated. So here is a quick reminder of long division. Okay, remember, for long division, you only look at the first terms anyway. So we only are going to pay attention to these two, right? And we're going to ask ourselves, what would happen if I divided an x squared out of an x cubed? What would I have left? An x, right? So I'm going to kind of wedge that in between these two. It really shouldn't go above either one of them. Okay, do you remember what I do with this x then? Yeah, you multiply down, right? So x times x squared is, of course, x cubed, right? And then we subtract, right? So what happens to the first term? That goes away, right? And what do we do with the next term? Bring it down. So notice, like, I can't do this anymore, right? Like, I'm done, because I can't divide an x squared out of a 1, right? Which means this is my remainder, right? And what am I supposed to do with the remainder in this? I'm supposed to ignore it anyway. Okay, so the slant asymptote is just what we got up here. So the slant asymptote is just y equals x. So it's the equation with a slope of 1, that's it. Okay. So we were kind of rushed at the end of class last time, but remember I said I'm not going to make you graph these, I'm just going to make you find them. Okay, so what I will make you graph is vertical and horizontal asymptotes, but slant asymptotes, we probably won't mess with that. Okay. Okay, so the last thing from this section, and then we are going to move on to something else. So I want to look at 2 common rational function graphs. Remember, the word rational just means fraction. And then I'm going to ask you to remember something from test 1, that we're going to make some applications for this new rational function graph. So here are the 2 kind of basic looks for most of the rational function graphs you'll have. So let's look at what the difference between 1 over x, the graph is, and then what 1 over x squared looks like. So here's the graph of 1 over x. It is probably the more common of the 2. It's got a curve on the right and it's got a curve on the left. But the most basic one is 1 over x. Okay, we're going to talk about how we might be able to change that in a minute. Okay, so the same type of graph when it's 1 over x squared just looks like this still, but this left piece is actually a mirror image of it. Okay. By the way, you might be able to figure out why that is, right? What kind of numbers am I always going to get when I square numbers, no matter if they're negative to start off with or positive? Like a negative number squared is going to be what? Positive, so that's why these 2 stay up above the x-axis, whereas this one, this part's negative and this part's positive. Okay, so you don't have to really know that. But what you do need to be able to do is you can actually, from Unit 1, you can apply all 6 transformations to these. Okay, and if you've forgotten that, you might be able to refresh your memory in section 2.5. In other words, these are the simplest /parent functions, and so we can make some changes, and then we should be able to describe what that's going to do to our graph. So probably on test 2, I would be more likely to ask you to describe for me what's happening than I would be for you to actually sketch it. So let's do an example where I ask you to do that with kind of a variety of different ones. So I want you to describe the graphs compared to the graph of f of x equals 1x that we showed above. So you won't really even need to skip too much space between these, but let's write all of these out first. And this is not all of them, but it's a good start. So when I say describe, I don't really expect you to sketch it. I just expect you to kind of explain to me what's different. Okay. So before we go on, just know that all of the above graphs will have the same general shape as 1 over x. So maybe we don't have to explain that every time. So it'll be that 2-part curve kind of thing. So my question really is, like, what change needs to occur? Okay. So hopefully you remember section 2.5 and you don't have to go back and review it too much. Okay, so what do you notice about this function? It looks the same, except what did I do at the end of it? I subtracted a 3, right? So do you remember what kind of shifts happen when you add and subtract a number at the end of a function? It's up or down, right? But because it's minus 3, it's going to be what? Down, so it's going to be shifted down 3 units, right? What if it would have been a plus 3? Then we would have said what? Up 3. Okay. All right, so let's talk about this one. Okay, what do you notice about the plus 2? It's not at the end this time. Where is it? It's inside, right? So what kind of shifting was inside a function? Left and right, correct? So remember, this is the oddball one, right? So which way does it actually shift? Left. Okay, so if it would have been a minus 2, it would have been to the right. Remember, horizontal shifts are opposite of the direction you might think. All right, so what about this one? We have 2 shifts happening, right? We have a shift of what according to this? Right 3, and then what is this going to do to the graph? Up 4, okay? So this would be shift right 3 and up 4 units. Remember, you work from the inside out, so technically you would do the right shift first, right? Because that's the one on the inside. And then